Check. Am I on?
Go ahead, sir. Your mic should be hot.
All right. Okay, good afternoon, everyone. Welcome to MIX, and thanks for coming to this talk. So just to get an idea, how many of you are Windows Phone developers today? Wow, that's a good number. Thanks for developing Windows Phone applications. And for those of you who haven't, I strongly encourage you to download our tools and build your first Windows Phone app. So with Windows Phone 7, we released a great set of tools, which provided you single-click install and download, high-definition performant emulator, top-of-the-line designer support with Expression Blend, and all this bundled in a free Express queue. We received a lot of good feedback. We have more than 1.5 million downloads of tools today. And based on some of the feedback and other competitive analysis that we did, we are making our tooling story even richer by adding new features in Mango. So let's take a look at those. So with the new release of Windows Phone, the developers now need the ability to not only build Windows Phone applications, but build Mango applications as well. With our new release of tools, in a single set of tools, you will be able to target both Windows Phone 7 and Mango platforms. Also, with a single click, you will be able to upgrade your existing Windows Phone 7 applications to Mango. As you would have heard from Andrew Klinick's overview talk and the keynote that we had, one of the biggest features that we are bringing in the runtime is multitasking, where you'll have multiple tasks, foreground and background, running for a single application. From tooling perspective, we are going to provide you debugging support across these tasks as if you're debugging a single application. Developers now have the ability to both target Silverlight and XNA platforms in a single application. From tooling perspective, we'll provide you great template support so that you get good starting point. One of the topmost feedback that we heard from previous releases is people need a way to diagnose performance issues in their applications. And we now have a Windows Phone profiler to address that. We have a great emulator today. There's tons of applications that people are developing and testing on emulator. We are adding some new features to the emulator to enhance your developer productivity. So in this session, I'm actually, Scott touched upon some of these things in the keynote. In this session particularly, I'm going to look at profiler and emulator enhancements and drill down a little deeper into those two. So let's start with emulator enhancements. One of the things that we are bringing in Mango is making sure that the memory characteristics of the emulator are similar to that of device. So we have done significant improvements in that area. Having said that, I would still mention that all your performance tuning work you should do on the device. This is just a step to make sure the device characteristics and emulator characteristics are similar, but not the same. Also, H.264 is one of the most important codecs that's being used today for developing media applications, especially on the mobile platforms. In Mango, we are adding support for H.264 as well as ASE, so that our media development story in the tooling is much better now. There are a lot of applications today that use location and accelerometer APIs. We are adding support for both these things in our emulator. And I'm going to give you a little demo on both accelerometer and location. So let me start with accelerometer. So before I get into the demo, what are the kind of scenarios that you actually have which use accelerometer APIs? So let's say this is my phone. It's in landscape mode right now. Most of the games are written in landscape mode. Let's say you want to implement a car racing game. So you would want to play a game like this, where the phone is rotating around the y-axis. Or you may want to do some rotations like this, where you're rotating around the x-axis. So you need the ability to simulate these movements so that you can test these things in the emulator. Let me fire up a small demo which uses the accelerometer APIs, and let's see how we can use the emulator to test out that. File, new project. Let me create an accelerometer app here. Oh, OK, there's another one that exists. All right, so let me target the new version. Let me drop an image here from my toolbox. Let's set the source for that. Let me drop a phone image to this. Set it a little bit. Done. Let's move this away. All right, so let me go to my image here. Okay. Let me add a image projection. Oops, sorry. Image dot projection. Done. So what I'm trying to do is just applying some projection to the image based on the accelerometer readings here. This is done. All right. Let me add a reference to Microsoft device.sensor. That's where the accelerometer APIs are. OK, let's go here. All right. OK, did I give a name? Let me give a name to the plane projection so that actually I can use this in my code behind. Done. OK, let's go to the code behind. Let me add a using statement for Microsoft.devices.sensors. Awesome. Let's new up an accelerometer variable here. Nice. OK, let's register an event handler for this guy. Oops. All right, this is done. Let's start the accelerometer. OK, let's implement this. OK, so what I'm doing is I'm getting registering an event handler, taking the accelerometer readings, using those to apply a rotation transform on the image. Let's run this on the emulator. All right, so now what we have here is arrow button here to bring on the additional tools. So this is where you see the accelerometer tab here. Let's choose the orientation here. And you can choose the orientation here to portrait, landscape, flat, or standing. And you see here you have a 3D model of the phone here. And you can use this ping dot here now to move this phone. So you can move it like this around the x-axis or around the y-axis. Move it around. And you see that the accelerometer readings are now getting simulated, and the image is moving. Also, what you can do is we have a pre-canned gesture like shake, so you can play that. And you see how the app is reacting to that. So with this, we think that you will now be able to test more and more accelerometer API-driven applications on the emulator, and this will significantly enhance your productivity. So apart from accelerometer, the other thing that we are adding is the support for location. So today, if you have to test out location apps, you probably have to run around from pillar to post here, and carry your application around and test it. It's nice that now we have this support in the emulator. So let me open a simple app here, which is a very basic app. It's finding restaurants in the nearby area. And as you would have guessed, there is a location tab here in the emulator tools window. You can put pins here. And so let's see. Let's zoom this in a little bit more. sorry, zoom out. Okay, go. All right, so now you can see Seattle much better. All right, so you can move these pins here. You can move to Bellevue. Let me go to Bothell. And you see as I'm putting pins here on the emulator window, my app is reacting to it. So real time, the location data is getting fed at the device sensor level, and it's bubbling up at the API level, and the app is reacting to it. So here you can also see that we are giving the information about the current location, all the latitude, longitudes that you have pinned here. What you can also do is you can search here and go to Las Vegas, for example. What you can also do is this, what I was doing till now was the live mode. You can move from live mode into So if you want to do this at a certain periodicity from moving from one point to another, if your app is reacting a lot to the location, you can set that periodicity here and play. Also, what you can do is you can simply put a pre-recorded data in an XML file, drop it in a particular location, just choose that, choose the periodicity, and you can play that as well. So I think with these enhancements that we have on the emulator, we think that you will be able to test out more and more applications on the emulator. And once you have, so we're done with this. So once you have tested out your applications on the emulator, what you need now is to try it on the device and actually do the performance tuning for those. So that brings us to the topic of profiler. So if I look at some of the feedback that we are seeing on some applications in the marketplace, I mean, there are a lot of functional and great-looking apps today that exist. This is some of the feedback that I have seen from, for some of the apps which are functionally good, but not very performant. So for example, the app is very slow, it's sluggish, scrolling is not smooth. If I play it for a long time, it crashes. So these are all typical performance problems that we see there. And as Scott mentioned in his keynote, there are a bunch of runtime improvements that we are doing so that your applications can automatically take advantage of those. But there are a lot more things that you as developers could do to make some tweaks to your apps to make them much more performant. So what do you have today to do that? There is some good documentation available in terms of best practices, et cetera, that you can use. The only problem is it's a very, very iterative and a time-consuming process. You have to comment out some XAML. You probably have to put some debug spew. And you don't know when there is a certain problem as to what is the quantified impact of this on the performance of my application. So what you need really is a tool which can identify those problems. It can tell you what is the percentage impact to the overall user experience, and then guide me as to how I fix those problems. So what I'm going to do now is I'm going to show you a demo of a profiler. I'm actually going to use the same app that Scott used in his keynote. So this should look familiar to you. Let's close the emulator. All right, so it's a house finder app. I'm using this app so that you can relate to the problems that he already mentioned. And what I'm going to do is drill down a little bit more into how to use the profiling tools to identify those problems. So let's see. My device is connected here. All right, so I have an item in the debug here to do start Windows Phone performance analysis. I choose that. There's options here to do execution analysis and memory analysis. As a starting point, I would always recommend you to do execution performance analysis unless you already know that there is an issue with the memory. So memory you want to use when you know there is a memory issue and you want to do detailed analysis of memory. But starting point, use execution performance analysis. Let's launch the application. OK, it's trying to, oops, failed to connect. All right, let's try this one more time. let's make sure this guy is connected here. Seems to be. Okay, let me open up my VS one more time. What's the fun if everything goes well? So, all right, let me give it one more time. Launch application. Okay, this time it's deploying the application. So let me show you the device here. So this is the Home Finder app. It comes up. It's taking a time to get started up. Probably took around 6 seconds. Let me scroll through this. Scott told me that there are a lot of runtime improvements that I did, but still, I think there's room for more improvement. So there's probably something that I'm doing wrong as a developer. So might want to see if there is any option there. OK, whoops. There was a jerkiness there. Let's show it one more time. Yep. OK, so I have run the application now. Let me exit out of the app. And let's go back to my VS. Oops. OK, let's do one thing. I have a pre-canned data there as well, so let me just open that guy. So here you see that there is a whole bunch of data that we have received here. So let's spend some time on this thing. So the first graph that you have here is the frame rate graph. It gives you per frame FPS value of every frame that got rendered during this time sequence. The second graph is giving me the information about CPU usage. So the green one is the CPU usage on the user interface thread. Now, that's the thread that you would be most worried about as a developer, because that's the one that's blocking the interactivity with the application. Then you also get the information about the memory usage across the run. So you see how it's hovering around 50 MB here. You also see that there are some storyboard events that are getting triggered there. At what point the images are getting loaded in this particular sequence. When are the GC events firing off? So in totality, it's giving you really a picture of the overall health of your application. So now if I relate back to the problem that I saw that it took some time to get started up. Then I saw some choppy scroll, right? And it's very evident here where there are frames which are getting rendered at 60 FPS and then suddenly dropping at 30, giving me an indication that the frame rendering is not smooth. And therefore, the scrolling is not that smooth. Also, when I moved from the second control to the third, it was very choppy. So the frame rate really tanked at that point. Now that I know that these three problems are represented in my overall summary graph, I want to look at them one by one, section by section, and drill down as to what is going on with those in those areas. So I figure out where the problem is. I select this area. And immediately you see that there is performance warning. So there is a performance pattern analyzer which is fed with all the heuristics and anti-patterns that we have seen based on the experience that we have on Windows Phone 7. And based on that, it's giving you certain warnings. And not only is it giving you a warning, it's now telling you that there is a problem. What do I do next as a developer? So it's going and telling you to go and inspect the function summary to drill down further. So from here, let's get more space here. I go to the function summary. This is a CPU sampling profiler, which is collecting samples of every function that got hit during that timeline. So I immediately go and sort on the inclusive samples here. One more thing I want to show here, which will be of a real value add here. It also is giving you the thread name on which this sample was collected. So you can correlate that, OK, all this activity is indeed happening on the UI thread in this case. So you sort on the inclusive samples. You see that there is a bunch of measure overrides happening, a lot of framework code getting exercised. is there something in the user code that I am doing which I can change to make this faster? And there you go. These, the functions which are highlighted in blue, these are the ones which are the user code functions. So I select the first function that I see which has the highest samples. From these functions, I can actually go to the function called tree. So now I know this is the user code, this is getting hit maximum number of times, and this is the call tree. This is the context in which it is getting called. So let me go ahead and scroll down to see where it's getting called. Keep going down. House finder, get new listings is calling parse JSON. I click here, and guess what? I actually go to the source code of the file where that is implemented. So now I know exactly where this function is implemented, and I can browse through this function and now take corrective actions. So for example, in this case, you may want to decrease the amount of JSON parsing that you're doing here, or move it to some off-thread worker thread so that it doesn't block the UI thread. So from the point where you identified the problem, it gave you a warning, it told you drill down into the functions view, and it actually took you the function which now is actionable to you as a developer. Let's go and look at the second problem. Let me zoom out a little bit more so we can see the frames a little better. So here you see it's like a Coombe pattern, right, where there is high FPS, low FPS, giving me an indication that the scrolling is not very smooth in that area. Select that area, and immediately I get a bunch of warnings. What are the warnings I'm getting? High CPU usage in layout updates, moderate CPU usage on UI thread, and again, it's giving you a warning and telling you where to go next. So in this case, it's telling you to go to the frame summary and visual tree summary. So from here, let's go to the frame summary. So this is for every frame that got rendered, you're getting a bunch of data here. What is the duration that it took to render that frame? How much time was spent in CPU? What was the percentage that was spent in CPU versus GPU? So if you want your frames to be rendered super smooth, what you want is bulk of the time to be done in GPU, right? So here, if I want to now figure out which frames are taking most time, I just sort on the CPU time here. I figure out the frames which are taking maximum CPU time. Now that I have this frame information, what do I do next? So from frames, I can actually go and see the entire visual tree that was used to render that frame. And for that visual tree, you have a bunch of information here. What is the total draw time? How much time was spent in measure? How much time was spent in arrange? And how much time was spent in updating the textures while rendering that visual tree? So simply here, I just sort on the draw time, right, and keep going down. So the ones that are again highlighted in blue here are the controls that you have written in your XAML code. And the ones here are the ones that runtime uses. Runtime is templatizing those things. So keep going down. This 490 milliseconds, 487 milliseconds, keep going down. And then you see here this 484 milliseconds. And then there are a bunch of listbox items in that, right? So there is listbox items. Each listbox item is taking 100 milliseconds, and eventually that's causing 400 milliseconds on the stack panel, eventually causing a high draw time for that frame. When you look at this thing, you can see also that out of this draw time, how much time is getting spent in measure. So here, if you see, out of 484 milliseconds, 361 milliseconds got spent in the measure time. So clearly indicating that this visual tree is getting recreated. So what are the possibilities that could be? So at this point, you can really now, you have the information at each and every element level as to what is the contribution of that element to the overall draw time. So you can do two things here. You can now make optimizations. Now you can refer to those best patterns and practices and actually make some modifications to your XAML. And before making modifications to XAML, you would know what is the kind of impact this can have if I change this XAML element. So in this case, if I see that the measure time is taking too much, let me go back and again look at the function summary. and see if there is anything, again, in my user code behind that I'm doing to impact this measure time. So you see here that there is measure override, which is taking the maximum amount of time. And let's scroll down to see if there is any user code that's getting. Here you go. There is a user code. There's a convert function that I'm using in the code behind, which is taking 22% time of this overall measure time. So I go here, go to the call tree, validate that it is indeed getting called in the context of measure override, click on the convert function, and here I'm doing some string concatenate operations, which is taking a lot of time. So here you see that there was a visual problem which is related to two things. There is something that I'm doing in my code behind, and there is a possibility to improve something in my XAML as well. And the profiler is giving you a view of both these things together, so you can do step by step, you can make changes to your XAML now and make it more performant. Let's go back to our profile, and let's drill down into the third problem. So the third problem here is a very, very evident problem. The frame rate just tanks. It goes down to like 10, 15 milliseconds, 15 FPS. This is something that you would certainly want to improve, right? Select this area. And in this particular case, you're getting a very, very prescriptive warning. Very prescriptive warning. Cache invalidations due to animation of a cached visual. What does it mean? It's saying that there is a text block that is cached as part of items presenter, and it is getting updated every time because you're running some animation on text block, and that's causing your parent control to redraw. And that's why the frame rate is tanking. So just to validate this thing, in this case, you're getting actually a very prescriptive warning where you can go directly from here to XAML and change. But let's validate this with a frames and visual tree view. Frames, sort on CPU time, select the frame which has the maximum CPU time, go to the visual tree, sort on the draw time, scroll down, and see what's going on here. So you see this is a wrap panel here which has draw time of 253, and then there are those list box items which are taking time. If you select this, from here itself, you can now go into the storyboards view. So you can now see that these are the storyboards that are running at this point, which is causing your wrap panel or the list box items to get redrawn. If you see here in this, there's a storyboard name, the element which is getting redrawn, what is the target property on which it's animating? So in this case, it's animating on color. And it's also telling you that this is a CPU-bound animation, right? So now you know there is a CPU-bound animation that you're running on a text block, which is causing the list box items to get redrawn. And that's why that's where you need to go and fix. Click on color animation using keyframes, and you're there. So this way we took 3 simple problems, very common scenarios of startup time being slow. So startup time being slow, go to the function summary, see that you're not doing anything to impact the UI thread. A visual problem, which potentially has scope for optimizing your XAML, as well as changing your code behind. Third problem, very common problem where you get cache invalidations because of some animations running. Sometimes you don't know that there's a CPU-bound animations, and therefore you're not able to take corrective actions. Profiler is giving you very prescriptive detail as to what you should be doing. So recap on Profiler. It's really giving you information of the XAML constructs and the typical C# function, hot paths, memory analysis, everything integrated into one. Second key value prop of the profiler is it's giving you warnings based on built-in heuristics that we have collected based on the feedback that we have already received. And it's giving me warnings, and it's also giving me step-by-step guide as to what I should be drilling into next. So with this, I think you will be able to identify most of your performance problems with the profiler, I hope. And it's really going to make you more productive and building better and more performant applications. So that brings me to the end of the session. If you guys have any questions, I can take this at this point.
So I'm assuming this works for XNA too, right?
It works for XNA too. So for XNA, it will give you code profiling information for CPU and memory. Yes.
Is there any plan for support for motion sensor in the emulator?
So today, we have support for the accelerometer. We are actually evaluating at this point to see if we can do some minor enhancements to this to enable support for motion. But at this point, it's not there. Any other questions? All right, so if there are no other questions, we are also running a user study on Profiler, which is going to be 4 to 5 p.m. in Palm A, and tomorrow 9:30 to 10:30 a.m. in Palm A. So you can bring your source code if you have performance problem with your applications, and we can sit one-on-one there and run it by the profiler, and it can help us get feedback on the profiler, and hopefully you will be able to find the issues in your applications. Sure.
Any plans for the support for this for the Silverlight for the browser?
At this point, I cannot make any comments about that. We don't have any firmed up plan to support this right now on Silverlight 5 in browser.
Thank you.
All right, that brings me to the end of the session. Thank you all for coming for this talk.